Up next on the FF Cossack channel, live from the Åland Islands, we follow the exciting story of a man cleaning glue out of a power supply. A manufacturing choice by Seasonic left this power supply helpless in the fight against this corrosive agent. Follow along as parts are desoldered and put back in place, right here on the FF Cossack channel. How's that for professionalism? Right, so it is indeed, as I announced, this is a power supply made by Seasonic. It is an ATX power supply, pretty standard except for form factor, and this goes into a giant touchscreen PC I've got under these pants here. But let's just give me an overview of the live dashboard to make sure we're actually live. We are live, excellent. So yeah, this is not going to be a very exciting job. It is most exemplary of boring electronics repair, because I'm gonna try and get some kind of a shot of it. We've got this dark patch between the blue cap and this choke is conductive glue, and anytime you see this yellowish goo like this, it's just bad news. It turns conductive when it runs hot or has a voltage across it, and yeah, they've stuck it across a resistor which seems to be both running hot and having a lot of voltage across it, so we gotta fix that. And since this goes in such a cool device, I've got a video coming up on it. I really want to get this thing running. And yeah, when I made the mistake of actually plugging this in at first, and it made crackling noises and there was smoke coming out, so yeah, I'm hoping we haven't caused any additional damage. But this is mostly just gonna be a shit ton of desoldering gun action, because we need to get all the components around the glued part out. So I'm gonna have to take this capacitor out, I'm gonna have to take this choke out, and I'm kind of worried about what's underneath this heatsinky thing, because there's you can't really see too well underneath it. It looks relatively clean, but I don't quite trust it. And we have got a bunch around the primary side cap, probably want to take that off as well. So yeah, let's just get soldering. We can start with the cap, then the choke. And it does help if I actually put the soldering cleaning sponge in the water before trying to use it. That does help. Everybody loves the desoldering gun. And I'm going to use crappy cheap solder for this, because it's just sacrificial. No point using quality stuff. As you can see, this roll is entirely fucked up because it's got two ends coming out. The chat is alive, I'm glad you're there. Hello everybody. How many people are actually watching? Hey, 27, that's not bad. Well, if you're just showing up, you just missed the intro, and that's your loss. This is pretty much just going to be an hour or two of me desoldering components and scrubbing glue over this PCB, so don't expect anything too exciting. Oh no. And it is a double-sided PCB, which is the weakness of this thing, because it's like these desoldering guns are very traditional. Unlike ones like my OE 2901, which has the heater in the tip, this one has the heater in here and the tip just firmly coupled onto that. So this thing has almost no continuous thermal transfer capability. So if I try to solder a high thermal mass board like this with a desoldering pump alone, I'm not gonna be able to actually heat it all the way through, because the tip is gonna chill down too quickly, which is quite the bother. But I'm gonna turn the temperature up to 430 degrees Celsius, and we might stand some kind of a chance. If not, I'm either going to have to preheat the board, or I'm going to just have to double iron it. use the 2901 to actually preheat the pads before trying to suck the solder out. This board does have a very horrid looking solder spludge right there. That does not look very well made at all. Oh, there's some dirt on there as well. Seems to... This is actually tracked over between these 2 points at some stage. Could have been some dirt or a bug or something. People are saying good morning, good evening and good day. Good morning, good evening and good day to you as well. Let's see if we can get that one joint to come loose. Oh, we're desoldering it without even sucking the solder out. It works. This is a surprisingly high thermal mass board for being just a tiny power supply. Let's clean those holes while we're at it. It's always much easier to just suck the solder out after you've removed the component. So that's the blue cap out of the way, and that gives us a much better view of our problem. That is not good. Not good in the slightest. So we're gonna have to take this choke out as well. Hopefully a lot of this dark burnt stuff is gonna come out with the choke. And there is a resistor underneath there. I'm really hoping that's not failed, because we're never gonna be able to find out what value that actually is. So the choke is gonna be these 2 solder joints. I'm just going to preheat the board with the 2901, flow some fresh solder, and then I'm going to try and desolder it with a pump. We'll just heat that, try and get as much power down into the copper. Quickly grab the cow and suck it dry. That worked very well. Very well indeed. Oh, are we entirely out of shot? We are entirely out of shot. There we go. Now you can actually see what I'm doing. Shit ton of solder on there. Grab the pump. That should be a big choke. Yep. It is coming loose. Oh, whoa, look at that. Oh, wow. That is... Oh, it's run so hot that it's actually melted the plastic. Jeez. This glue. At any time it's darker than light yellow, that's going to be conductive. So I'm hoping this hasn't... it also turns corrosive, so I'm hoping it hasn't corroded through the copper on this choke. That would be very annoying. Jeez, that's absolutely horrible. Almost as horrible as my glitchy soldering iron making beeping noises at us, as always. We need to fix this. I'm just gonna put some alcohol on this solder tip. Hopefully that's gonna keep it running for the evening. This is getting uncomfortably hot to hold. Ouch. Please work without making beeping noises. Someone says, careful not to pull the track off with a glue. That's not going to happen because the glue is very, very brittle. It just falls off. As you can see, I just pulled it off the choke there. I need some tweezers. And pliers and everything. Side cuts as well to clean this off. And a wider angle, else I'm just going to be out of shot constantly. Someone asks, have you ever considered a soldering gun for such high thermal mass boards, or does that beefy iron work just fine? A soldering gun? I'm not sure what you... Oh, right, like the pipe working stuff. No, never. Because those are also usually... This fucking soldering iron, fucking hell. This makes me angry. This makes me angry. This has now turned into the fixing my soldering iron so that we can keep working live stream. Because I am very easily annoyed by random beeping noises. This is how you disassemble one of these pens. Let's see. Oh, come on. And these connectors never work properly. As you can see, I've been fixing this thing before. We're going to take a Q-tip, try and clean it out. It's a shame the soldering iron just doesn't seem to have enough contact pressure to make a reliable connection to the tip, which makes it screech at me. Yuck, just look at all the dirt in there. Could just, hopefully it's just oxidized. Jorno says, soldering iron, fix unsolder the buzzer. That would not work because it actually sets the temperature wrong every time it beeps. It can get like very, very hot when it's not connecting properly. And you can hear how there's actually arcing going on between the tip and the soldering iron pen. So it's just, if we don't deal with the actual problem, it's just going to ruin my tips. And no one wants to have their tip ruined. We just need to stroke it a bit every now and then to stop it getting ruined. Perils of cheap Chinese knockoff soldering irons? Maybe. It's just kind of a, I would say, a flaw in how this general tip system works. I can't imagine a proper Heiko or anything being much better. Unless you just have, well, yeah, I guess if you have super strong springs in this, it would work a lot better, probably. The newer AOE pens are a lot better. Like this mine is ancient. It's like, geez, could be from 2010 maybe. It's been around for a very long time for being a cheap soldering station. And they released a new one like a couple of years after I got this. And I got one of those at work. It's much better. It still kind of does this beepy thing sometimes, but it's just way better in every way. Someone says, can you just push the contacts in a bit? I have. The way this is made, and you're not going to see it, they can't be pushed in too far, else you'll just be unable to fit the tip in. But I think we can actually re-push them a bit here without making it unusable. We'll give it a go. Oh god, I think I overdid it there. Let's see if we can actually fit a tip into this. Oh yeah. I think this might work. I think this might work. So let's just alcohol this. Give it a bit of a rub and then get back to work. Yeah, no crap coming out. Hopefully this is going to work now. Also the this thingy, what would you call it? I don't remember what these are called. It's absolutely worthless in this model. It's just not stuck on anything. Strain relief, that's the word, strain relief. It doesn't relieve strain at all, in the slightest. Ugh. It does, however, give you a lot of strain when trying to reassemble this thing. Grr. This is not usually this tight. Grr. Grr. Yeah, I feel like I'm ruining my cable. I am ruining my cable. That's not good. Oh well, we'll just make do without it for the time being. I'll find the time to reinstall it at a better date. Someone says bit of spit. I'm not sure. I don't like spitting on things. We could try a bit of water though. We will try a bit of water. That's kind of working. Yeah. Or we're just ruining the wire more. I'm usually good at sliding things over long, thin things, but clearly not tonight. Almost there. At some point this is just going to go snap, because this is cheap Chinese cable. Yeah, that's good enough. That's good enough. Now it's at least there. It's supposed to be snug against the pen, but we're not going to get that in any reasonable amount of time. I don't think this is installing right now. Let's see, if there's supposed to be 3 clicks, so... That could be. This could be on there. Let's try and pair it on. Yeah, it's heating up. There's heat coming from there. That works. Good. Back to the matter at hand. Hoping that thing's going to shut up now. So we've got a choke for cleaning. Yeah, this has kind of worn through the lacquer on the choke, so that's not good. I'm hoping it's not ruined. Let's get rid of this LCD protective sheet I'm using. No point getting rubber all over it. Ugh. If you're getting into general electronics repair, you're going to be doing a lot of this stuff. Because this is such a common failure made on almost anything. It's really rather silly. You find this in everything from cheap Chinese crap to super expensive industrial gear. And the soldering iron's not shutting up. This soldering iron. This needs a bit of a toothpick. Yorno asks, by the way, is your lab PSU still blown? Yes it is. I have troubleshot it, and I've got the parts list, but I haven't ordered it because I haven't had time. Rather, I haven't had money. I think this is gonna be good enough. I think this is gonna be good enough. Yuck. This is horrid. We can get the webcam kind of down. That's better. You can actually see what I'm doing. Okay, so now we get to move on to the actual board. There's a fair amount of crap in there. If we have a look, we've got this stuff there. Yeah, that's going to be the main issue, and some... Oh no, that's going to be the main issue right there. This is where the smoke came from. And yeah, this is just going to be cleaning up required all over. Let's get some light in here. Let's zoom in. So if we can be all out of frame, because I don't have a monitor. My only monitor for this stream really, that's accessible, is my laptop there, which is looking at the YouTube stream, so it's like delayed by 10 seconds. And if I want to watch the live preview, I have to turn my head 90 degrees, no, more like 110 degrees to the right to watch the other computer. Ooh, this is not looking pretty at all. I hope that resistor is not blown. Let's give it a measure. It's got 2 orange bands, so I would imagine it being 3 something. Oh, that's going to be... is that 3.3 ohms? That would probably explain why it's running hot. Is that actually going to be 3.3 ohms? Let's give it a bit of a further clean and try and see the bands. This glue never dissolves properly in alcohol, but it helps to kind of keep the little chunks in place. Can we see some bands on that, I wonder? Orange, orange, golden, white. Orange, orange, gold, white. Let's quickly see what that means. I will cheat. Orange, orange. I would imagine that actually is 3.3. Golden. White. 333 gig ohms. No, I don't believe that. Is it perhaps silver? I said silver. That would make it 33k. No. Maybe I'm doing everything wrong. Yeah, it's going to be 3.3 ohms. I mean, it just makes sense. But we're going to have to desolder that and clean around it a bit more to stop a horrible conductive path that's formed around it. So, where's this is going to be? Those 2 points right there. I think. Where's my solder? There's my solder. Brace for cow. I did not heat that for long enough. That might have worked. 1 and 3, the others 3. That's our resistor. Yuck. So dirty. If I have another 3.3, I'm just going to replace that cell. I'm going to check. And I do not have a 3.3 ohm resistor, so we are cleaning this up. We are cleaning this resistor. He's a good resistor. You're a good resistor. Belly scratch. Yeah. I don't really care how clean it gets as long as there's no conductive path across it. "54 people are watching someone scratch a resistor." Alright, let's just get back into cleaning the PCB while not losing the resistor. I would be happy to have some kind of really coarse brush, but I don't think I have one. Kind of. This is like a spray nozzle brush, so we'll just... I like how they've gotten goo inside the isolation slot. Conductive glue, rendering it entirely useless. Have you tried a fiberglass pencil? I've used those in the past. I don't like them because they leave fiberglass everywhere. I just use them when I really have to, because I don't like having fiberglass in my hands. This really would be a prime job for an ultrasonic cleaner, but I do not have an ultrasonic cleaner. You can really see how it's been tracking around there. Pretty horrible. Yeah, there's a spot there where it's really formed a decent track. Right between a couple of points between there, this via, and that hole there. It's just tracked across. That's probably where the smoke came from when I tried to power it up, so we're gonna have to scratch that off. I usually use a small screwdriver for that. This is one of my favorite tools. It's one of these tiny screwdrivers which just snapped, and it's incredibly sharp. I usually use this to scratch tracks off of PCBs. Works very well. Q-tip, alcohol, get the residue off. How's that look? Pretty decent. Pretty decent. So do we have any more bad stuff? Not really. But I can see from this angle, but I do believe, yeah, we've got a bunch, yeah, right there, down in there, between the plastic and the tiny transformer. It's run too hot. Snap. Just look at how hot that's run. Entirely discolors the plastic. or it's because the goop has turned corrosive, because it does turn corrosive. Yuck. So, there's not a lot in there though. Not a big deal. I kind of want to... Yeah, we're going to be desoldering this transformer because I want to just get rid of all the goop that's stuck on it, because it is turning darker and it will start becoming an issue sooner or later. Since this is a PC power supply, it's going to be plugged in pretty much all the time, and yeah, that's not a good thing. Ah, didn't go all the way through. Stupid high thermal mass boards. I'll just preheat by adding some solder to all of the joints. That just gets some base heat into the board, as well as adding a bit of a leaded solder, which lowers the melting point of the original stuff. That's better. On these dual layer boards, you can usually see if you've sucked a hole decently by just, if you look, you're not going to see it on camera, but if you look down into the hole, you can see silver. That means it's still attached to the top layer of the board, and you're gonna have to resock that, else you will destroy your board when remove the component. Also, you can usually hear if there's a decent slurping noise, like this. Now that wasn't a decent slurping noise, actually, because it didn't heat all the way through. Now, hang on. If you look really closely, you can actually see how this one is not actually desoldered. These ones have decent black circles around them. This one's silver. And if we grab these guys, let's use some decent tweezers. These aren't decent tweezers, but they're tiny. These pins move around slightly, whereas this one, it really resists any kind of movement. I can feel it's not attached by more than a smidgen, because the tin is kind of yielding. Solder. The solder is kind of yielding to my bending, but it is not desoldered. So I'll just add some new solder, heat it up for a long time. And then try again. Someone asks, can you zoom in a bit more? No, I can't, because this camera is bad at close-ups. There we go. I can give it a slight try, but I think we're just gonna, yeah, we instantly run out of focus. That's as close as we're gonna get. Sorry. Let's just preheat this one from the start, since we know on this one we know that most of the thermal mass is going to be on the other side of the board, because there's no track going from this solder joint to anything on this side, so the track is going to be on the other side of the board. Oh, that's decent. These are all decently desoldered. Yep. Wiggle, 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 and wiggle. Ooh, this is no fun. These all go to a giant track, probably ground. This is gonna take a lot of heat. There's no way the desoldering pump would do this on its own. It would not stand a chance. Jacob asks, how does this even happen? Does this even Jacob, are you doing okay? Perhaps you shouldn't have eaten those pills. Oh shit. Even though we preheated the board, it did not solder properly. If there's no slurping noise from the desoldering pump, it's not working. So we're gonna have to dual wield this, I think. That's better. I hope you heard that. Let's try and do that again. Oh yes. Excellent results. Someone says this is turning pornographic. It always was. Do you not find me sexy? Right. I believe this transformer should just pop out. Oh. It's glued to the caps. We will have to liberate it. There we go. And we need to mark which direction this goes. We definitely need to mark which direction this goes. We will do pink there to pink there. Yeah, good thing we took this out. This would not have turned out very lovely at all in the long run. It would have turned corrosive and started eating at the insulation of a transformer. Adria asks, is that glue conductive too? And the answer is yes. All of this glue is conductive. All of it. Every little bit. Let's see if we can just beat this off. Percussive maintenance actually works. We kind of don't want to destroy the E-core transformer though, so we need to be rather careful with this. Thankfully this glue is very brittle. So if it's stuck to something that's kind of malleable, it will usually just crack and fall off. But if it's stuck to something hard, that's worse. Our yuck is almost all the way down to the leads there. That's no good. And we're almost out of frame. This is annoying. I don't want to destroy the plastic wrapping. Journey Jacob says you have much more patience than I have, and the answer is no, I don't. I just have less money than you do. And also this is the power supply for a very, very, very cool device, which I really want to revive. So, I do have some inspiration. Someone says, this isn't Big Clive, though. Sorry to disappoint. I am the bastard offspring of Big Clive and Louis Rossman. There we go. It's time to turn into something. These pliers, by the way, I highly recommend. I can't spell the name, but you can see there. I buy these from Alpha. They're absolutely gorgeous. They are much harder metal than any other pliers I've used. Even pliers, side cutters. They beat Knipex many times over. These are an absolute piece of trash compared to these. If you try and cut steel wire with these, they're fucked. These will do anything for a very long time. I highly recommend them. Lucas Heinrich asks, why do companies put this glue in there? In order to keep components in place and sell more product. Alright, I think this is turning pretty decent. Just a little bit left there. Yeah. I'm happy with that. It's good enough. Could have been a lot worse. So what's left? We've got some down there by the TO220 package. So we will clean that out. Out you come. It's probably not showing up on camera very well at all, but this leg of this diode has been covered in the goop, and it's just turned grey and horrible due to how corrosive it is. Some of the PCBs I've worked on which have been affected by this stuff, usually really old ones, they've actually had the goop go underneath the tracks, and they've eaten the copper away from the inside. So you can have a track that looks fine, but if you touch it with the tweezers, it just disappears, because there's just the thin layer of solder mask there, and there's no actual copper track underneath. Those issues can be rather interesting to track down. They usually turn out expensive to the customer since, well, it takes a very long time to find. Nitro says there is one big problem with what you're doing. You ain't forcing the magic smoke back in. You're only removing this magic smoke containment goop. I would wager that this is not magic smoke containment goop, but rather magic smoke release aid. There's a good word for that, but I cannot find it in my head. Snippety snip. Out you come. Magic Smoke Extraction Accelerator. Lucas Heinrich asks, how old is this PSU? I believe it's from 2010. It's probably seen quite a bit of use. It was used in an industrial environment, probably powered on 8 hours a day, in a big TV, so... I'm gonna just zoom back out. Zip. Let's see if we can get this to come off nicely. If we just grab it very gently, poke it, it should just let go of the PCB. There we go. Beautiful. Beautiful. Perhaps we would be well served by a knife. Adria Garcian asks, I wonder, is the exposed metal cap on the caps insulated, or does it correspond to one of the leads? Depends on... Usually it is insulated. Sometimes it isn't, so you should just count on it being connected to something. That went decently. Oh, it went decently out of frame. This scoop, I don't think it's going to be much of an issue because it's just attached to some plastic. I'm not going to bother taking that off. That's clean enough, I think. Oh, here's a challenge. Lalman Puya Mizo asks me to pronounce his name. Lalmuan Puya Mizo. Or Lalmuan Puya Mizo in English. Oh Jesus, 70 people watching. That's impressive. Welcome to the Cleaning Power Supply stream. This is exciting. We are removing glue. It's like watching paint dry, except inverse. So, yeah, judging whether or not to remove this, we have to get rid of it because it is covering. Let's get this in shot. The goop is covering both of these leads, so this is going to turn brown. It's covering this lead and this leg of this device, so that's going to turn brown. And it's covering several leads of this little TO92 package there. So we need to get rid of all of that. Which is a bit annoying, because there's just quite a bit of it around. But it has actually started to let go from a PCB right there, so I'm hoping we can just coax the knife underneath and poke it up. Yeah, that's going well. Oh yeah, look at that. It's probably not going to be visible on camera, but it's actually started to turn brown on the inside by the legs of the TO92. That would have led to issues in the future. Oh Jesus. I hope we're in frame. Yes, we are. Someone's talking about wooden cases in chat. If you want to make a wooden case, make sure you have a Faraday cage inside it. Else you're going to have EMI issues and kill all your neighbors' radios. Yuck. I think we need to desolder this TO92 package because it's just too dirty. So I'm going to take a couple of pics of this to have a backup. Then we'll be back online. What the hell is this thing doing? There we go. Device backed up. Someone says they're not watching me to remove a glue, they're watching me to slip the knife. That's not going to happen. I am not Big Clive. I haven't cut myself on a knife in a very, very long time. So the TO92 package has the flat side against the yellow cap, I'll remember that. And we will remove it. Maybe we can just solder all three legs at once with the soldering iron. No, there's too much stuff around it, it's not gonna work. By the way, if I were doing this for a client, I would actually not be as thorough as I am now. But this is something I want to keep for myself, because it's such a cool device, but I'm gonna fix it very properly. That did not solder properly. Neither leg desoldered properly. Great. desoldered properly? Maybe. Oh, fuck's sake. This is not coming off easy. There we go. Better. Whoa, there's a resistor across that, which we almost knocked off. I'll have to remember to solder that in. Ow, 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 ow. Very hot. Very hot. One leg is still slightly attached there. There we go. All three legs are loose to a decent extent anyway. So we should be able to just poke this out. Yeah. It's coming. What are you? KA431. So this is a TL431 voltage reference. We do not want that to be conducting wrong, because that's going to give us incorrect 8-bit voltages. Yeah. Let's see if we can get you guys a shot of this. It's all brown in there. All brown and horrid. Just look right there. You can see it's much darker than the rest of the goop. Not good. Away you go. Be gone forever. Stop causing us issues. Right, now our TL431 actually has a chance to work properly. If we actually take the time to pick the goop out of there, that is. There we go. And now I actually need to get that little tiny SMD resistor, which I almost knocked out completely out of place, back where it's supposed to be. If I can find my proper tweezers, that is. There they are. These are my expensive tweezers. They've got a brand, Ideal Tech. These are like 12 euros. But they are considerably better than cheaper ones. You probably can't see any of this. I am sorry for lack of visibility, but I actually need to see what I'm doing here. We've got 1/2 of the SMD resistor soldered. That's easier to do under a microscope. But sadly, I am not Veros. I cannot afford a microscope. Yet. It would be fun to have a microscope. Would be very fun indeed. And I think this ought to be decent. Yeah, haven't knocked any components out of the line. People are saying #haircam. So I'm also going to resolder this choke here because I was knocking it so hard with a screwdriver to get this crap off that it's put a lot of strain on the solder joints. They're probably not going to be bad, but better safe than sorry. Does not take many seconds to do. There we go. And we do have more goop in. Oh, fuck's sake, we've got goop in between here and that transformer. That's horrible, and this big piece of burnt plastic. Yuck. Disgusting. Amir Khan asks, why are you doing this? And the answer should be rather obvious, because I want to have a working power supply. This thing belongs to a giant touchscreen monitor, and I desire to have a giant touchscreen monitor. Because who doesn't want to have a giant touchscreen monitor? This is annoying. This is pretty awful. This is pretty awful. Amir Khan says, sorry, I thought it was a standard power supply, in which case I'd bought a new one. I agree. I agree 100%. But this is not a standard power supply, it has a weird form factor. So it is worth repairing to some extent. Oh man. I want to mount my lamp better. There we go. This is coming off quite nicely, and you cannot see anything. I wish I could just shoot this in 4K and have people crop it on their own. There's actually conductive goop. Like, there's an optocoupler in there, and there's goop across the optocoupler. Jeez. That's just downright dangerous. I do not decide to have a conductive path from the primary to the secondary. That is a very bad thing. Someone asks, why don't you take off a vertical PCB? And the answer is that is more work than it's worth. because I can see, you can't see, but I can see that there's no goop. There's no goop in there, there's just some there and some here, and I can get that without taking the board out. Since it's a dual layer PCB, it is rather annoying to desolder stuff from it. It takes quite a while. So I don't do it unless I have to. I think we want to undo the mains cap though, because that's just big in either way. It is discharged. Negative terminal towards the outside of a board, I'll remember that. People are talking about this power supply. It's not just a small form factor power supply, it's like an integration power supply. This thing doesn't have a case, it's just a bare PCB. So I don't think you can get anything like this for under a couple €100. And I don't like buying new things if the old things can be. Did this? So a good thing about this, oh yeah, 431D, no 474A plus desoldering pump is it comes with a sleep timer, so it turns off if you leave it sitting. But it also turns off if you use it, and the maximum timer I believe is 1 hour. So this is turned off now. It has probably been off for about 14 minutes. Alan Slater asks, how's the new workshop layout working out? And it's working out absolutely perfectly. It is excellent compared to what we've had in times past. Anyway, while we are waiting for the desoldering pump to heat up again, I'm gonna do that back in a sec. We are back, and I think the desoldering pump should have heated up now. Oh, you have a flushing. Yeah, you hear the bathroom flushing very well in this basement. Let's just reheat this. Oh dear. This is not going to be easy to desolder. I will give this one more try, then I'll just give up. Amir Khan asks if I remembered to wash my hands, and yes, I did. I am extremely pedantic, actually. I couldn't exit the bathroom without washing my hands. Hey, that actually came off. Fair enough. I'm surprised. It usually is very hard to desolder snap-in capacitors from boards like this. Very hard. But hey, who doesn't like hard things? I'm probably gonna... Wow, one of the legs has actually broken loose. See, the thing about desoldering snapping capacitors is the legs are kind of kinked. The legs go like if we look through the board, the legs of the capacitor goes like so. So it's always going to be touching in the middle. And that makes it very easy for the solders to just kind of grab on and be very hard to pull out with the desoldering gun. But that's come off just fine. Just needs a small amount of persuasion and it's gonna be out, and I am happy we did that because yeah, there is goop underneath it. Oh, and it's starting to turn brown too. Yuck. This would have started to eat through these tracks in some time. Someone asks, what day is it in Suomen tasavalta? I have no idea what tasavalta even means. I don't speak Finnish. What do you take me for, Finn? Off you come. Annoying. Scratchy, scratchy. Off you come. Horrible goop of death. 2V is in there as well. Oh dear. Out of frame. These two V's were under the goop. That would have caused issues. Because this goop turns conductive. It's really horrible stuff because it turns conductive either if it runs warm or if you put a voltage across it. It's probably slightly conductive from the factory and just turns more conductive with time. Come on. Out you come. Out you come. There's brown goop between the legs of his little riser board. That's no good. That means there's been stuff conducting around here where it shouldn't. How's this? Not quite clean enough. Whatever, there's a small piece in there, but I can't be bothered. I cannot be bothered taking that out. We'll just stick to the bigger chunks. Oh dear. Just look at her, that's barely even mounted. Unless there's something holding it down. That we cannot have goop. Goop is death. Amir Khan asks, how did it come to you like this? How did it pass OC? Oh, QC? Well, this power supply has been fine for many years. I mean, it's been in service since 2010. So it's been working just fine. Someone asks, have you measured the glue with a multimeter? How do you know it's conductive? I used to measure this with a multimeter in the past, and now I'm just using experience from doing that to know that it is conductive, because this shit is always conductive. Ah, there's some more right there. And let's try and stick a meter into that brown blob and see if we get a reading. It's usually about a megohm. That's not really the worst stuff. It hasn't quite turned dark yet, so I'm not sure if we are out of battery. Yep. Welcome to the replacing battery in my multimeter stream. Because I am not fetching another multimeter. What can I say? Taiwanese girls, a tight fit. Where's my screwdriver? There we go. If you have one of these meters, I do recommend using 9V or lithiums, because these last so much longer than a normal 9V. Like my meter is a Bryman BM869, which is a rather power-hungry meter. You can use several milliamps, up to 50 in some modes. So you really need to have a decent battery. There we go. And back in the sheath you go. There we go. Okay. Back to the top of your hand. We'll put that there. Let's stick our probes and the brown goop. Let's see if we get a reading. Yeah, there you go. That are probes in the brown goo, but like several millimeters apart. And if I rule it proper, 20 meg. That is conductive. That is very conductive. 10 meg. Now that's not even a high value resistor. Just look at that. I'm measuring. Like that is about 8 millimeters between my probes, and still we are getting a reading. So there you go. Brown goop, conductive. Proven live on camera. Let's get rid of that, shall we? Hollow. This one was in a rather annoying place. Out you come. The worst part is we actually had that brown goop in the isolation slots between the primary and secondary of this power supply. That is not good. That could... I wonder if this was filed in the proper report, they could probably get in trouble for that. If enough people, or rather if someone high enough up in the chain of command noticed. Because I'm pretty sure it's not legal to sell a power supply with a conductive path from the primary to the secondary. And it's not as if they don't know. Where's the primary, secondary? Let's see, it's going. Are these? Yeah, that's all secondary. There's a plastic sheet in between here, and I'm considering whether or not I should put that back. If this was primary and that's secondary, I would have to, but since both of these are on the secondary side, primary side runs like so. I don't have to. We can make without the plastic sheet. Not a lot of goop left, I don't think. Not that's of any consequence, anyway. There's none in between there that I can see. There's some on the caps, but it's not forming any conductive paths, so it doesn't quite matter. It's really just this little blob in the corner that could become an issue, so we're going to get rid of that and put out all the components back in place and see if this thing runs. One last blob. We can just mark that one. There we go. That is good enough for me, I think. Yeah. Oh no. we need to get this still, because that's between some component legs. Off you come, you piece of trash goo. Why are 89 people watching this? Ouch. That's sharp. Oh. We are so close to a finish line. There we go, a bit of mongering with the screwdriver still, and it's going to be good enough. There we go. Reassembly time. I hope I haven't lost any parts. Where's my 3.3 ohm resistor? There's my 3.3 ohm resistor. In fact, let's measure this 3.3 ohm resistor just to make sure it's not destroyed. Please do not be destroyed. Come on. 3.89, that is higher than I like to see. Because this is orange. This is a 3.3 ohm resistor. I do not like the fact that this is not 3.3 ohms. And 3.89. How far? Yeah, that's just way far out. It's almost 20%. So, I think we need to figure out a way to construct another 3.3 ohm resistor. Perhaps I got a couple of 6.8s we can put in parallel. I need to check. What is this? 75 ohms? No, that's wrong. Is this 6.8? I think this might be 6.8. No, it's 68. Damn it. I've got 7.5. What's that divided by 2? That's going to be closer. That's pretty much the same thing, so let's just take two 7.5s in parallel and see if we get something that's close to 3.3 than what we have in this piece of trash. I think it's good that we get more mass in this resistor too, because I think the entire standby part of the power supply might be running through this thing, because it seems to be kind of in the path to a little transformer there. Let's see how good this is. This is probably not a very critical value. So that's 3.88. And this is 3.89. 3.9 as it heats up. So really, yeah, 3.9. These are pretty much the same, so I'm just going to put this in. The fact that it's new and hasn't been subjected to the horrible corrosive crap, it makes it a better choice. And that's supposed to go there. Ugh. This PCB really looks disgusting. Very disgusting. I just want to give it a bit of an extra rub. Squeaky clean. Yeah, there was a bit of trash on there. In you go. I said in you go. Please do not have leads that are too thick to fit. No, perfect. That is a good result. That is absolutely perfect. I like that. We just need to get this soldered up. That's where we are. We are in frame. Hooray! There we go. That is in place. Solder even flowed all the way to the other side of the board. Excellent. Someone says, I missed because I was late, but what PSU is he working? Is he repairing? We are fixing a power supply that came out of a giant touchscreen PC. It's this thing here, actually. It's a 42-inch industrial monitor with a tiny PC inside, and this is a power supply for a PC. It's just putting out, you know, ATX, nothing too particular, but it has a weird form factor, so it's worth fixing. A new one's going to cost a fortune. And I like fixing things. Let's zoom out. Being my own cameraman for this is giving me a headache. At least the soldering station shut up. In before beep. Someone asks, will you also make a video on the PC itself? And the answer is very yes. because it's such an awesome device. I'm actually just this live stream is between shooting a couple of segments for that video, because I've shot a few segments up to finding this issue, and now I'm going to fix it, and the next segment is going to be and now I've repaired the PSU. And as you can see, I've now repaired the power supply, so let's install this and see if this thing works. So expect that line of a video, or something like it. I don't script my stuff. So we've got our choke. It went this way around, not that it should matter. And we've mongered it so much that the pins no longer fit. That should work better. In you go. Good boy. I know, since it's a toroidal choke, I guess it's a female choke. You know, since it's got a big hole in it. Someone called me sexist for saying that. Such an insensitive joke. Dick. Where the hell did that one pin go? Damn it. I've soldered this wrong now. That's annoying. Stay in place, you cursed thing. People are talking about hot glue, and I should point out that this is not hot glue. Hot glue does not turn like this. Hot glue is good. Hot glue is not bad. This is some kind of special industrial planned obsolescence creator. Alright, that is the choke in place. Kind of needs a bit more solder, but whatever, it'll stay there. It's fine. Now we're just missing a transformer and a capacitor. Transformer goes there, pink to pink. I am using my ring finger to press the transformer in place while soldering with my thumb and index finger. You need to have good hand coordination for this. There we go, sacked it down. And let's solder the super high thermal mass ground plane. There we go. Solder in silence. Perfect. Let's clear the holes for the big cap, because I apparently forgot to do that. And that's such a big plane, we're gonna have to preheat that a bit. good. I actually wanna... There was... Yeah, it's weird. There's something's tracked across there from... Let's see. This is gonna be a mains input right here. And this is the mains output. So something's just gone BAM and tracked right across there. That is not good. And this really looks dodgy. Like, there's a big solder splodge for no apparent reason and a lot of dirt. I think this power supply has been touched up by someone in the factory that's been warranty returned. Or it was just a bad one. Oh, that's actually, there's a component in there. Okay. Let's just clean that up a bit. I do not like the look of it otherwise. Yeah, a bit better. Ugly, but a bit better. What are we missing? We're missing the little big blue cap. Just a suppression cap could do without it, but I like my electronics running cleanly. I'm having internet issues because of poorly shielded electronics actually, so I have no excuse to be bad on that front. Since I live rurally, there are a lot of electric fences around here, and apparently when you have enough electric fences running along the telephone lines, it knocks your ADSL out completely. So for the last few months my ADSL has been dying several times an hour. The only reason I'm able to stream this is because I've also got 4G. So that's a bit of a bummer. I am not particularly happy with the telephone company at the moment. Oh, fuck's sake. This is annoying. It does not just want to be cleaned, this hole. This power supply's got dirty holes. She's a bad girl. Someone says they bought a set of Logitech Z623 speakers and people are telling them that they've got bad caps and semiconductors. Well, you shouldn't have bought a set of Logitech speakers. That's your problem. Alright, you shouldn't buy a set of Logitech speakers if you're looking for anything more than, you know, basic PC speakers that last you a year. Someone asks, is that water or vodka? It is water. I weigh 65 kilos. If I were to down half a jug of vodka, I would not be soldering straight tonight. Someone says, enough data to stream would cost a fortune in Germany. And in that regard, I must say I am very happy with all the ISPs around here, because none of them even offer a plan with limited data. I cannot buy a mobile or landline plan with limited data. They are all unlimited. It is fantastic. Okay, so that should be all the parts back in place. Let's give this some power and see if it bursts into flame. I'll leave a nice skid mark on my brand new desk. I will zoom out. I need to get some wiring because this just has... Whoops, these leads, we're gonna have to clamp on it. can I reach the power outlet from here? I cannot. So I'm gonna have to get an extension cord of some kind. That's annoying. I wish I had my your normal live power supply service when I wouldn't have to plug this to the live mains. But I guess that's life. So we're gonna be good here and just poke some copper pieces into this Apple power cord and clamp onto those. If I can find any. Perhaps these work. No, not quite. Should get a quick test. That would be a smart move. But also less exciting. That's not going to work at all. That's too thin. Kind of, yeah. Not doing that. How are we going to power this properly? How annoying. I don't want to fire off the whole TV thing because that's going to be horrible to get in frame. This is very annoying. I'm just gonna have to extend my banana plugs because I don't even have any. Oh yes, I do have the normal extension leads. Jesus. There we go. A proper pink rattly extension lead. Let's make sure that this is actually powered off before I go sticking leads into the mains, and that is powered off. Good. So we will clamp onto there and clamp onto there. And then we'll poke those in the power outlet. This is excellent. And then we will install a meter. And I don't think this has... Oh yeah, it's an ATX power supply, so it's going to have a power on pin. So we'll just start by powering it on. And monitoring the 5-volt standby. Is that the blue or is it the purple? I think it's the blue. Now that's not making contact at all. So I'll just try to power it on without measuring anything. Right, contact. It's screaming. It peaked at 12 watts, so let's try that again. It's drawing 3 watts, that's not very good. Drawing 3 watts in standby and screaming. And something's warm, could just be from soldering. So, what could cause that? We do have an Ost branded cap there. I'm just gonna measure that cap and see if it's any good. With a magic ESR meter that is not available for purchase. And which is not plugged into the computer. Zeroing ESR mode. This might go snap. Nope. Oh dear. I think this capacitor is fucked. Are we measuring properly? Yes, indeed. This little electrolytic is rated 100 microfarads, but it is 0.42 microfarads, and it's got an ESR of 123 ohms. Let's see if I can get a screen cap for that. That's rather ridiculous. Do I have a screen? Thank you, whoever pointed out the audio died. Yeah, let's just screw that. I can't easily get a screen cap with audio working right now. So I'm just gonna measure a couple of these caps to be sure they're not horribly out. The caps which usually fail are the low voltage high capacitance ones. But they seem to be fine. Not surprising, they're quality caps. But yeah, even if we had no audio during the test, this cap right there is fucked. So I will find a 25 volt 100 mic cap. And I've got a 100 microfarad 55 volt cap. Let's unplug this from the mains so that I don't accidentally nudge the breaker, which is right by my knee, and fry myself. I'm sure that would make an interesting live stream, but I rather wouldn't. Someone says they're waiting to see if anything exciting happens. Usually that's not the case. I usually am good enough at what I do to not have explosions. Sadly, it's not good for entertainment purposes, but it is good for achieving working products. And achieving working products is what we're here for. And also watching IKEA lamps. Negative goes towards the big blue cap, I think. We will find out. Yep, negative towards the big blue cap. I'll just put a new cap in there. In you go. In you go. Be a good little capacitor. Go into the holes. Go inside the holes, you little twat. Come on. For fuck's sake, these holes are tiny. Am I really going to have to... Yeah, I'm going to have to evacuate those a bit more. Because when these holes are not made for quality caps, the holes, they're not big enough. You need to have every drip of solder evacuated. That might work now. In you go, please. There we go. It's a bit dodgy, but it's in there. There's the part where I put my hand across the primary cap and get a giant shock. Alright. I think we're ready to try again. Go on, I blow my nose. Okay, make sure the power is off. Power is off. Let's poke these into the lead. Be ready to measure the 5 volt standby. Contact. and it's quiet, drawing 2 watts, which is a bit more acceptable. There is no apparent smoke, drawing 1 watt. This is a somewhat old power supply, so I think that's within spec. Let's measure the 5 volt standby. Ground there. ATX connector. Annoying. Right, that's probably the negative 12 volt. Then we will try the purple. I can never remember these leads. Hey, we've got 5 volt standby. Excellent. So let's try and power this thing on. I will need my switch. I will fetch my switch. I can't find my switch. I have a little switch which is perfect for testing ATX power supplies. It has to be around here somewhere. I guess my switch is poked into some power supply somewhere, so we'll just use a jumper. Shame. Hey, hang on. My switch. My beautiful, beautiful switch. This thing is lovely because it's got these tiny pins which you can shove into ATX connectors. I love it. I absolutely adore it. So now we'll just shove our probes into, give me a Molex. We'll check the 5 volt rail because that's usually where they regulate. So 5 volts fine, everything else should be fine. And we will put our switch in the connector between green and ground. And we will hope for 5 volts on there. Here we go. 5.13, drawing 6 watts. No smoke. Let's check the 12 volts. 12 volt is fine. Let's just check everything else. That's going to be 12 volt. That's going to be probably negative 12. No, that's 5 volt, okay. That's going to be another 5 volt. I never remember these sub voltages on ATX. This is going to be 3.3. This is going to be whatever white is, -5. It's going to be whatever blue is, -12. Yeah, -12 is never ever accurate. And there's going to be another 3.3. Excellent! This thing works. We could... I'm just going to shove it into my resistive load just to give it a little load down on 8 ohms just to see that it doesn't conk out. So I'm going to fetch a lead back in a sec. There we go. So we've got 8 ohms in this lead. Let's just shove that into the 5 volts. See if it doesn't explode right away. Oh, that's a bad idea. But it's going to work better. Let's measure the 12 volt, because since this is probably a group regulated power supply, the 12 volts should go up quite a bit when we load the 5 volt down. So we are now going to load down the 5 volt rail and measure the 12 volt rail. So let's turn the switch on, and indeed it is loaded down. It's drawing about 12 watts from the grid. So we're putting current into the load. 12 volt rail has raised. 5 volt rail is gonna still be pretty close to the, what was it, 5.13 we saw before. No, 5.02, yeah. So it's working just fine. And we can try. Like for demonstration purposes, let's load down 12 volt rail as well. So with the 5 volt rail loaded down, you can see we've got 12.16. When I switch to loading down the 12 volt rail, that's going to turn into something like 11.7 or something, because there's usually no feedback from the 12 volt rail at all. So I just disconnected it now. Let's connect it up. Yeah, it actually is regulating quite well. It's drawing 28 watts and putting some current into the light. That's regulating better than I would think. Decent quality base by this. Not bad. Power off. Sweet. So that is one repaired power supply, and that will be the end of the stream. So I will have to thank a lot of you for watching. I cannot believe 99 people have been watching this for a while, and I'll be seeing you around. Cheerio.